lot of people on. This is good. I love it. Cancel out a bunch of stuff. And, please start on time. Yeah, okay, I understand that. So go to, I'll paste in the link here. It's actually a forward, but a couple exciting things about Pipeline the last month. Actually, that should be HTTPS, but either way it'll work. Go to quickstart.pipeline.ai. So everyone start here, and keep in mind, for full context, we are building a company before your guys' very eyes. We want your feedback. We're very opposite of traditional Bay Area, where people go into stealth mode for 6 months and come out with something that may or may not fit the market. So we do this regularly. Strong open source project. Here is, actually, if you all could go up here and star the repo, that would be fantastic. We have done enough sampling with VCs where they appear to be worth about $1,500 in seed funding, every single star. So that'd be great if you guys could go up here and click that star. In fact, looks like I haven't even starred, so maybe I'll star it as well. We do ask that you install this CLI, and we want to know what problems you have in this CLI. Also, I should also post, okay, let's see here. Let me post the link for join slack.pipeline.ai. If you can either chat here or chat in that. There's a general community Slack channel that we have that we certainly address as stuff comes in. So we get a lot of good feedback there. All right, someone's raising their hand. I don't really know how to look at this. For those of you raising your hand, just send me an email. Or not email, just shoot me a private message if you want in the thing, and I will repeat it and then answer it. Okay, so quick start. Install this thing. This is the first step. And what we're doing here is we are giving you guys access. Now, this is the other link that you'll need. So we'll be doing a little bit locally, but we're going to actually drag and drop. So the context here is we are going to take a trained model, and if you want, at the end, we could actually train the model and then go through the end, and then go through the rest. But to speed things up today, we're actually going to take a trained model and get it, on our local laptop and get it into the public free PipelineAI Community Edition. Okay. Oh, it looks like we have there's a 9-month-old baby on the line. That's great. Excellent. Let's hope he or she asks good questions. Okay, so install this. And let us know if you have any issues with firewalls. We can get you around that. If you have any issues with, VPNs, anything, we want to know. In fact, that's a huge reason why we do these things. This is very useful for us, both in terms of usability and any issues people could potentially abandon these next few steps here. Okay, so once you get that installed, again, let us know if there's any problems. You should be able to run this pipeline version, and I'm literally going down the line here of inside of this community quick start. Okay. Some people are asking about the pricing model, that kind of stuff. Yeah, let's talk about that. We could either talk about that at the end. I can explain the pricing model. This is a community event, so I want to de-emphasize any commercial stuff, just out of respect for those that are here for community purposes. So run that command, then run this command, pipeline version. and let us know that you're seeing the version. You should. So I'm going to have a command line up here. I got this over here, like a million windows open. This over here. And okay, so let me install, let me install the actual CLI itself, make sure it works. You don't need Conda, you don't need anything like that. We use Conda internally. You can certainly use Conda if you like, if you're into that kind of thing, but we try to make this as accessible as possible to everybody. So let's see. All right, so we got that. So we install the CLI. Next, run pipeline version. Make sure that this is, so this is going to be the bridge between, like local environments and then, so do I have, okay. Next, we're going to click on this community thing. So we will be here, community. We're going to follow these instructions. Yes, everything that we're doing today is to get stuff into this community edition. Keep in mind, community is free, it's public, it's open. We're going to be dealing with samples today. You can upload your own models. I would recommend, talking to us because we can actually, right now, save as, the save as button in the upper right here is actually, it's not currently active. We feature flagged off the functionality, but the button is here for conversation's sake. We can, we can manually do this for you basically, where save as is really take this environment and save it into my own VPC, right? Or create me my own private domain, subdomain. So it would, let me take, if there's a Mary on the line there, it would be mary.cloud.pipeline.ai. You can get your own, it's all SSL locked down. So that's the save as feature, and that's where you really want to put your models. If you're super like sensitive about security, and models are derived from data, and data is private, and models then have to be private. They're not as easy to tie back to an individual user, but they are, should be treated as private as the data that was used to build them. Share, this is, you'll get credit, when you share your specific workspace with somebody else. So keep in mind right now, the current version of community has like everybody all in one. We're actually coming out with the, each week we do a release pretty much every Friday. Sometimes there's one in between for like bug fixes, things like that. But by the end of this week, we'll have it such that you can go into community and you'll be isolated within your own space. So that's a little better, but we really do encourage you to do the save as, and we can get that going for you after today. Share is where you would share the workspace, so you would get credit for actually sharing this with your friends. You get a free month or something like that. We haven't exactly worked that out. Okay, so let's go back here. Quick start. Here's everything. Download these models. So these are sample models. You should be in the home directory or wherever you want to put these, and run that command. I believe I've already, well, I'll do it along with you guys here. So this is going to pull down these sample models, and we have tons of models. We have TensorFlow and Scikit and all kinds of stuff. So let me see if PipelineAI models. So this is literally what the repo looks like. We even have, I think, a bash model in here. So we treat models just like we treat any function, except, regular functions are deterministic. You pass in data, they're, typically going to pass the same data back. They don't necessarily degrade over time like fraud models that are put out that are, relevant today, but might not be relevant in the future. So that's actually one of PipelineAI's kind of core competencies, is our ability to, trigger and notify that a particular model in production is starting to degrade relative to how it was like 1 week before, that kind of thing. Okay, so if the models are there, then let's do Actually, let me paste that here. What's the repo again? Yep, I'll put it right here. Okay, it's dangerous. Oh, I think that it's, okay. Can people still hear me? I'm seeing things that they can't hear me. Yeah, so leaving, my work PC does not install Docker. Oh, you don't need Docker. Sorry. Yeah, make sure that you're clicking, you don't need Docker. All you need is, this is actually a big change from the last time, where we were actually building, I think, Docker images locally. So community is essentially the remote version. And Docker Kubernetes, you know, well, actually, like SageMaker is remote. Yeah, Kubernetes can be remote. So all you need is the models from GitHub and the pip install CLI-pipeline above. Okay, so if Brett is on the line, I want to send him a note on the seg fault because we actually were seeing that. Okay, and if you do have any issues in the future, just find us on the community. So it looks like a couple people are in there. Meeting is now, yeah, okay. So repo we got, yes we can, okay. Can hear you fine, you don't need Docker. Says Docker's requirement on the GitHub page. Let me fix that. We just added the community stuff today, or last night. So yeah, just ignore the Docker thing for right now. You won't need that. Okay, are all models in PMML format? No, only a small number are in PMML to demonstrate support for those using PMML. Everything is in as native format as we can get. TensorFlow is in TensorFlow format, TensorFlow serving format. Keras is in Keras, and then we export it as TensorFlow serving. So Pipeline's all about performance of experiments and models in production, and that's what we're going to demo today. Okay, so you got your models, change directory into models. So you should see something like this. We're building up a better XGBoost. That's one of the things on the plan for either this week or next week. And yes, you will need to log in to community using 6 or 7 different, using one of 6 or 7 different social logins. Yes, H2O models are supported. We currently don't have a sample. Currently don't have a sample H2O model. You can certainly submit one or send us informally, and we'll make an example. And we actually do have on our community page, we used to have a help in the bottom right. I'm not sure what happened to it, but there's a help in the bottom right little thing that pops up. I think I probably disabled it because we were demoing last week and it was kind of annoying. You can click that and actually search for articles. You could also go to help.pipeline.ai. And if you search for H2O, you'll see some information comparing us to H2O and Domino Data Labs and some of these other folks. Okay. All right, so let's keep going. We're at 9:20. Let's see here. All right, so let me get my screens back in order. Oh, I see. Yeah, that's where it says Docker, doesn't it? Okay, and I think the other screen said Docker as well too. Yeah, certainly not needed. If you have Windows. Okay, are there other people seeing the seg pulse? We've seen it in some cases. Is this a big blocker for people? Okay. All right, so you should see a screen if you so change into your models directory, and you should see essentially all of these models. Today, just so that we're all doing this together, let's follow along on the community README here. So this is where I am. Boom. And we don't need Docker. We just need Python 2 or 3. We've already installed the CLI. Run this ls command. Boom. So ls should show this, and probably a few more because we test quite a bit with MSv3. Okay, git clone will be this thing up here. I posted it up above a little bit, but I'll certainly, oh, I know what's going on. I think I probably posted, yeah, so git clone, boom. Okay, and it's also should be at the top of this page. Yeah, it's at the top of that README right there. Okay, so moving forward, we'll see some files. So some of these things we generate when you upload the model. Some of these you can actually customize and then overlay. Is there sound? Hello? Okay. Yeah, okay, people can hear. Okay. So listed out, you'll see the one that we'll want to crack open, because today we're focusing on invoking a TensorFlow prediction. And we actually have a couple different versions. And in fact, if you take a peek at community here on the right, you'll actually see, let me post that link in here. You'll actually see we have 4 different versions of the MNIST model. So actually, yeah, if we just go, that should take you to the home page. You'll have to log in, use your GitHub or use your Twitter, whatever you got going on there. And you can select, yes, any one of these. So this is one way to do like today's workshop is to actually select one of these. These are all the exact same model, but they've been trained on 4 different frameworks and they're being optimized in different ways. So for example, TensorFlow is being optimized for TensorFlow serving. So we're actually generating a new file format that's specific to TensorFlow serving called the saved model format. Some of you probably know. Scikit just using Python, so it's literally unpickling. And I could show you guys, where all this code is. But let's just walk through one today. There's PyTorch version of MNIST and Keras. And what we're going to do is we're actually going to put all these side by side and load test them up and watch them all take traffic. Okay, so let's crack open. I'm actually going to skip that one for a sec. Let's go to this one. You could do cat or, I think, what is it on Windows? It's edit or something. Yeah, does TextPad still around, or if you're using PowerShell, hopefully you can VI. So here's the pipeline invoke, and let's start off at the top. So this is literally the Python that will get that becomes part. So we take a model on disk and we wrap it in a Docker image, and we wrap it at the same time that we're wrapping it. We're also optimizing it. So that's why this front page here says optimize and deploy. So we're picking one. If we pick the TensorFlow version, it will always pick up the actual source code, but then there's certain tricks that we do afterward that I'm going to highlight here in a sec. So this is the actual file. And essentially this is a hook into our framework, into our platform, that whatever you want to put in here is what's going to get executed. And so this is where here we're actually like initializing a TensorFlow serving model, and we tell it like where to find it. By default, it's going to find it in a directory within here. Model pipeline TF. boom. Okay, so this is, if we go one more layer, this is the save model format. So we've actually optimized this. We have prepared it for serving, and now we're just literally going to archive this up, drag and drop it. So there's a bunch of different ways to get models in. You can go through the home page, which is a sample. You can, so either go through the home page, you can introduce a new model with this plus button, which is actually what we're going to do today, so hold off on that. There's also a command line way to do it. I believe the command is deploy, where you could actually, it'll archive it up for you and do everything for you. But today, let's go through the steps. So I was just kind of showing you guys what's involved in a prediction, which is like why we ended up here. So let's see, pipeline. And again, this is the bare minimum that's needed for this model to actually execute. Models. Okay. So just to back up real quick, so the invoke method essentially transforms the request. So the request comes in as either JSON, or if we're predicting behind a stream, it's going to pull in the avro, and there's a step that will convert the avro into like NumPy if you're using Scikit, or even with TensorFlow you can use NumPy as well too. So there's always this transformation step, and we actually let you either write it right now and upload it as part of the archive, or we will generate it for you when you upload the actual trained model itself. And like, just to be very clear, we do support model training. Today's flow is we're assuming the model has been trained. There's a lot of companies focused on training. We actually focus on post-training optimizations, and then the actual model serving. We come from Netflix, we come from Expedia, we come from very, very high scale, like microservice backgrounds, tons of like data science, the ability to push out models as quickly as the data scientists can think, right? This is our goal here, safely in production, and actually validate your models in production and create lots and lots of champions. And okay, yeah, Missy, can you paste that to all the attendees? Yeah, Brent right now from PipelineAI is not on the panelist thing just because of a checkbox. Actually, I'll just paste it here. Okay, can I find a version? So you likely may have a proxy issue there, but yeah, maybe Brent can like take a look at that. But let me keep going here. So we invoke this prediction. We're actually we're wrapping monitors around this. So we're using the Python context manager to actually put timings around every single step here. So this whole thing will be timed just by the nature of our platform. Right? And so this is for more of the advanced user, right? For the sort of casual user, you would just click, one of these things, you would push the model out, you would then send traffic to it, and yeah, everything would be fun and happy. If you want to actually get in and do custom transformations, and this applies across all frameworks. So Java, there's a way to do it in Java, and this would be Java code, right? C++, this would be C++ code, not Python code. So anyway, here's kind of what the transformer looks like. It's taking, and this is the demo app, actually. Cloud demo. And it looks a little bit busted because we actually tore it apart the other day, but you can go in here and predict. So let me paste this in. And this is actually hitting our live community. In fact, if you go and hit a bunch of predictions here, we can go into the models and actually take a look live at some traffic coming through. So yeah, here we go. Right now there's only, what, 3 models? Looks like a few people have been figuring this out. And if I go over here and I start clicking around, I could actually see traffic. Now there's a multi-cloud part of this that I should highlight, right? So keep in mind that that we can deploy these models across clouds. We can actually compare the cost. So, you know, here right now, yes, we could actually compare across all 3 clouds for the exact same model. So that's something you can trigger off of. Here's a bit of sample code here. So now this is actually splitting traffic between 2. I've kind of jumped ahead here just, you know, to kind of tie in the application side of it. Let me paste this in. Oh, yes, I already did paste in the that demo thing. And look, so there's actual real live traffic. Now, one thing I'm going to do, let's see, is there the Keras version, CPU? See if anyone's getting the Keras version. Oh yeah, so this actually tells you right here which variant is involved on the response. So sometimes it'll be the Keras, sometimes it'll be like different ones. So okay, so let me go there. All right, and then back to the actual hook into our platform. This exact same code works all in the open source stuff. Again, we're not building Docker images today, but if you follow the Docker quick start, you will certainly build Docker images with this exact same structure, these exact same samples, and you can run those. Yeah, demo's looking a little pokey to me too. I think, let me restart or just refresh the browser. Yeah, I thought I'd be seeing different variants here. Well, okay, so actually on that note, let's do something fun. Maybe we are hitting a limit here on the amount of CPUs. So I'm going to increase these to 5. So let me actually show you guys the Kubernetes cluster that's running behind here. But let's see. So I'm going to click apply. And this is going to start scaling up the what's this, AWS prod. So you could actually see now we only had one before, and now that's this one that was running, and now we have 4 more of these pods showing up. So pod is a Kubernetes term for, just think of it like a model server, and it has some sidecars that are attached to it for performance and tracing models and all that kind of stuff. So, right, like again, I'm kind of jumping ahead here. This is good feedback that it's slow. Let's see if adding 5 more will help here. So let's keep an eye on that. So let's go back to this. This is the actual code that's transforming the JSON. So in this case, in this specific demo here, with the digit thing, we're actually converting, we're converting this image into a JSON representation of that image. So it's a big 28 by 28 matrix. Every point in that matrix is either, all 0, or 0, or some, form of some sort of grayscale. We convert it, we reshape it, we do some stuff, then we're actually creating a tensor that's the input. And you could pass lists of tensors here as well too. These all get sent into TensorFlow here. The response comes back as a bunch of NumPy arrays. Oh, so we're actually converting this into tensor using the NumPy array that's built off of this JSON. This is very common code that you'll see everywhere, is converting JSON into NumPy. The response comes back from the predict, but again, we have to transform the response, because you typically aren't going to respond with right, like NumPy or a tensor. You certainly could, in which case this would just be a pass-through. You would essentially do nothing. But our transform, because we're connecting from jQuery and from JavaScript in a browser, we're converting the response tensors into an actual JSON array, or JSON dict. Okay, so let's go to the next steps here so that's all that this section is intended, and it should, and when we're actually labeling, so we generate all this for you, but we're when we're pushing out to our metric system, so to tie it together, I'll show you. So we obviously have these metrics here. That's kind of the last 2 minutes, but we also have sort of historical metrics here where we're doing. So we can look at sort of the overall health of the cluster. I can even see, and so I can actually drill in and find this model name and this model tag and type and actually compare it to the Keras version. I could build a dashboard for this. Yeah, all that cool stuff. So these are the actual application level predictions, right? So it looks like we had a spike here as everyone got on, and probably increase our disk here at some point soon, things like that. So, but this is more systemsy metrics. This is actually let's see, this is CPU usage per variance, okay? Haven't really talked about variance just yet. Let me keep going here with this. Go down here. Okay, let's actually get a model in. All right, so I'm going to run this next command. It fails because of your tag name. I want you to put in something unique. Okay, let's see, that's gonna archive up. So we've already trained the model again. This is pre-trained for the purposes of this demo. There's a trained version in the samples directory. We now have the archive that we need, and we're going to go to this link now. Actually, this is the same. Yeah, so you can get to this through the UI, but I'm just pasting in the link here. But we'll get to it by going to models. We're going to click MNIST because that's the model that we're creating. This is like a ridiculous comparison of many different versions of MNIST, kind of a Kaggle thing for MNIST. Let's see. So what we want to do. Oh, actually, back on that last screen. Let's click the add button. So here it says press the add button on the screen. Boom, boom. Add. Let's see. We're going to specify it again here. It's going to be MNIST. Let's see, this is like this 1, 2, 3, 4. I think I called it. You won't have to do this in the future. Right now, this is just a disconnect between our metadata offline on our inside this archive and our use of it within. So we're going to upload an archive. So I'm just kind of following along here. This creates our little drop zone. We're going to find this. Let's see, where is this on disk? If I open that, that's going to be not something I want to do, but let's see, we'll find it somehow. That's going to open. Oh, okay. So grab the actual archive that created it. So you could do open on that file, it'll open it, but it'll also pull up Finder. And just drag and drop it here. Click add. This is essentially creating, it's initializing the folder for this model. This model then gets uploaded, everything checks out literally, and then let's click next. Now, before I click next, I do want to point out an advanced feature here that we're still working on, but again, we want to get feedback from you guys sooner than later. You could actually modify. So this is the exact same pipeline Invoke that was in that directory that we uploaded, but we can actually make a last minute change. And let's say we know this one takes a little bit longer and we're going to give it 100 seconds for timeout, something ridiculous. Or maybe we want to modify, something here. Let's call this, Chris 1, 2, 3, 4, something like that, right? So you can make last minute changes. You can maybe, augment the response here specific to you. You can then click update. But when, and all the files are here, you could actually copy and paste in your dependencies. And so, for example, if we wanted to remove pip as a dependency and maybe change it to Python 3.5, I wouldn't do that. But let's click update, and that's going to update that. Then let's click next. All right. So now this model should be going in. I believe it ends up down at the bottom, I think. Let's see. See where it ends. 3, 4. All right, should end up here in a sec. So when the model comes here, then we can actually optimize and deploy it. All right, so it looks like someone's already created a PyTorch version. Looks like someone used your tag name. That's kind of fun. So let's do that one. So so these are all the models that have been ingested into Community Edition. From here, you would click Upload, boom, and it's really an optimize and upload step. It's not really just an upload, just like a traditional, CI/CD thing. We're like way past that here. So here I'm saying this is a PyTorch model. I'm going to create just the Python version. Actually, let me do this. I'm going to pick a different one because I want to talk about. Let's pick Keras. So Keras is here. I'm going to pick CPU. I'm also going to pick Python version versus the TensorFlow serving version. So we'll actually create the TensorFlow serving version for you that will work with this runtime. So that's kind of cool. These are right now feature flagged off. So some of these we have examples for. Some of them are specific to certain like customers. Like, so for example, Intel Python. I could actually, instead of using this just regular Anaconda Python, I could actually try the Intel Python, which we see, especially with Python 3, because of their aggressive use of like vectorization and like some of these advanced things, AVX, SSE, and they actually package in MKL, which is similar to like BLAS, the basic linear algebra subroutines. It's like the Intel version optimized for Intel chips. So this is where we start, if we're a sophisticated user and we actually do want to try a GPU version or try to serve on TPU or train on TPU. TensorRT is by the NVIDIA folks, so that's GPU specific. MXNet, you can at some point, even convert these into the Onyx format, which we support, but I think we're calling it MXNet here, which is probably not totally correct. But there's also this phase of post-training optimization. So we have a trained model from down here. We're about to deploy it, and now we're provided some things that we can do to the model as we're packaging it up. We can either take the 32-bit weights that have been trained in 32-bit, drop them to 16-bit, drop them to 8-bit. We can try, and each of these checkboxes, all combinations become a single Docker image physically. So, and they then get pushed out down here. So these are all single Docker image variants. So these come from people up here clicking and checking and then pressing deploy. So for this one, let's just try to get the Python version out for right now. These are all commented out for now just to keep things simple. You can also, any sort of microservice, this comes from Netflix and like this sort of thinking, you need to put in timeouts. That's why you saw here on the left screen, you saw timeouts being specified. This is a very high like timeout. It should almost never be 10 seconds, but we're going with it for now, right? You want these timeouts to be small. If you have any problems here, you want to be able to fail fast. And you also, if you fail fast and you fail fast enough over 20, 30 times, you can actually flip the circuit, right? So this is a dashboard of our circuits. This is showing any services that are have the circuit closed, which is good. That's why closed here is green. If we start pounding this thing with a ton of model predictions, we'll actually flip the circuit and then put our fallback in place. And you can literally define a static fallback here. We support functions as well. So, these are models. We're finishing up streams this week. Functions are essentially the exact same as models. They take inputs and they give you outputs. The cool thing about functions and models actually and streams is that you can compose them together. And so one thing right now, this is a checkbox, which doesn't really mean anything because there's nothing tied to it. But at some point, either next week, the week after, you'll be able to actually go into functions, or there'll be a drop down here to select the function that you want to trigger. And as long as you're not calling, other remote systems that could potentially be down, which is why this is timing out in the first place. Typically we suggest here for the fallback that, this is a static. In like Netflix's case, we would actually burn in a static list of the top 100 movies of all time. And whenever our circuits would open, which is bad, we would just start to return this static file that was on disk. And it was up to us to maintain that static file, and sometimes it didn't get maintained and didn't get updated properly, or the format changed and we forgot about it. But for the most part, a fallback should be as simple as possible with the least amount of network, database, right, like any of those interactions should really, at that point, you can only rely on the local disk. You can't rely on S3. You can't rely on like Google cloud storage, things like that. Okay, so we should see some more models popping up here. All right. So going back to here. All right, so take a model. If yours isn't showing up here, let me hit refresh here and see if anything's showing up. It looks like we got a couple new ones here. Yeah, Pipeline Workshop. There's me. Okay, so I'm going to take, and I thought I added, oh, wait, did I actually deploy this one? No. All right, so let me take the Chris1234. I'm going to deploy this. This one I'm going to use TensorFlow serving. I could also say Python, but I'm just going to go straight for the serving. And now this is going to bundle the static, boring, sort of lifeless model. It's going to wrap it in excitement and real-time endpoints for like REST services. Also, it will bundle it so that it can be a Kafka consumer. So there's two ways to start up models right now. Our sort of fast track quick start is a web service, but by the end of this week we'll have the quick start that will actually pull from a like Kafka topic. So when you start it up, you have to tell it which Kafka topic, and that's where these streams come in. So streams actually, you'll be able to launch Kafka brokers here. And then when you go to spawn a new model server, you could actually put it into streaming mode, which then you tell it which Kafka topic to read from. That's the input Kafka topic. And then it'll run the prediction, and then it will place it in an output Kafka topic. So, for us, these are just end up being drop downs, or the ability to like drag and drop and sort of compose these various pipelines from streaming data as well. We also support Spark jobs, and where this comes into play. So let me show you. We only have about 10 minutes left here, but okay. So I showed you guys a little bit about dashboards. Of course, we support TensorBoard. Kind of has its own first-class citizen. Here's Jupyter. So let's see. And because you're already authenticated, it should just go straight here, or maybe ask you to click the login button, but it already knows who you are. So that's actually just kind of a workflow thing. This is actually the full workshop. This is the one that, there's actually one coming up this Saturday. In fact, let me send you guys the link. And it's here in San Francisco. We haven't done an in-person one in a year. Well, I just did one a couple weeks ago out in DC, but this is, okay, this is what's going on right now. And this is, so we just put a pretty big discount on this thing, kind of the days leading up to it. So that's the full 8-hour thing. It just so happens that it's the Saturday after I'm doing this. I didn't plan that on purpose or anything. But that's the full 8-hour, and we go through every single one of these. These are actually, open source notebooks that are out there. Instead of pipeline models, there's pipeline notebooks. And you won't really be able to run these notebooks because they're specific to the GPUs that we're using, and yeah, that kind of stuff. So when am I coming to DC, New York? I'm there. My little sister lives in DC, so I'm there all the time. But yeah, shoot me up like a mail on the side. And we should have, yeah, Brent, if you're listening, can you double check the intercom thing and see why the help in the bottom right isn't working? Like normally we have at the bottom right, there's that little like annoying thing you can pop up, but yeah, all the meetups are there. There's another question, compare and contrast SageMaker. Yeah, so the cool thing about us is we are like Amazon AI partners. We actually just had a blog post. Let me see. Where was the blog post? Edit. Yeah, we actually just had this blog post the other day. Oops, the webinar chat. That highlights us against SigOpt and I think one other one as well too. A couple companies came to SageMaker very early. We're certainly one of them. So let me pop this up. Yeah, we love SageMaker. SageMaker. The cool thing about Pipeline is that we actually work and like integrate directly with SageMaker. So the Docker images that we create work across us and SageMaker. And let me see. So you could actually follow the SageMaker quick start that we have. So you know, while SageMaker is the infrastructure, you know, is similar infrastructure to ours, we actually support them as well. So there's basically no lock-in. You could use the exact same Docker image and upload it to, that you build off of this like Docker example. Actually, this goes through the entire thing as though you're starting from scratch. So and it will get those Docker images into SageMaker. And the cool thing is that you can then compare SageMaker to a Kubernetes cluster that you're running to a Kubernetes cluster or to, you know, PipelineAI, which internally we are using Kubernetes. So SageMaker does lack quite a bit of features that they don't do streaming data. They don't give you the ability to shadow traffic. This is one thing I always forget to talk about, but it's pretty important. Actually, let me pull up, I think on help, pipeline.ai, I believe we have, if you type SageMaker, I think I compare us here. Yeah, PipelineAI and SageMaker. So good question. I'll paste this in. But you know, our main goal is to give you the ability to experiment and compare. And, you know, we don't care if it's across SageMaker, right? Like, yeah, we're not charging the 40 to 50% right, like markup that SageMaker does. That's something to point out as well too, right? SageMaker is, if the EC2 instance costs $1, they are going to charge you $1.45. And so, yeah, that's something, right? Like costs always come, it's like pretty much, do I run, you know, it's similar to, do I use Kinesis or do I run my own Kafka? So maybe in the beginning, SageMaker works for you guys, but then very quickly you start to need more advanced traffic routing patterns, experimentation. Now, SageMaker supports traffic splitting, and that's just, you know, one of our features. So we can, okay, so my model did make it out here. So let's say I'm going to do 10% to this one, 5% to that one. This is telling me the overall percentage there. What do I want to do? 35 on this one, I think gets me to 100. And then I'm going to put this model into shadow mode. All right. So here I'm going to update this. Oh, and also we have auto scaling, so you can, you know, choose particular like metric to actually trigger off of. And set them in and the max, that kind of thing. We're still finishing up the UI work for that. All the backend work has been done for this stuff for a while. So now we have 4 models that are live, but we're not quite sure about this 5th model. So I don't necessarily want that 5th model for like whatever reason to be responding. I still want it to get traffic, to get the inputs, to get the features. And I still want it to make a prediction because I'm curious how it's going to behave. The problem is I am not confident that if I put it into production, it might actually cause people to leave the site or to unsubscribe or to cancel their, to like cancel subscription, whatever, right? Or not purchase the particular campaign. So let's just put them all out. So here we're putting them out. We're making sure this guy is up to 5. Looks like someone might have gone in and changed one of those. And now let's make some traffic here. I think we have to give it a or no, that's just the routing rules. That's fast. So now we should be able to predict. And hopefully it will. I think this page is like getting stuck somehow. But yeah, interestingly enough, we actually do have, so there's now 6 models down here, right? I think 1, 2, 3, 4, 5, 6. There's 6 models. Unfortunately, we have a bug in our UI that we were trying to fix right before this, where it's not showing all 6 of them. And you can see the top part of it here, but really this needs to adjust to the size of. And so let's hit this, and we should be. I think even back on the quick start docs here, we show fast way. So this is the SageMaker one. I actually want community petition. Go back here. You can either run this curl command, and it's going to tell you which ones actually come back. So if I keep running this, I'll see some cases I'm getting the Scikit version. Some cases I'm getting the, that's another one, Chris 1, 2, 3, 4. Here's Keras. So it's essentially spraying the traffic according to, oh, actually, I know what I can do here. I can do that and then grab this. This will let me see the whole thing. So this should be all of them now. You can see the full. So this is all 6, and as I'm spraying traffic, there's a way to actually do like a mini load test, which I want to point out. And this is the cool thing here. So I can predict, so you can either do the curl, or as shown here, you can pick different languages. So I could use Python, I could use jQuery, I could use Java. And these are all different ways to actually post that, from that same payload, that same sample payload, PHP. I think there's a few others that we actually don't have on there right now. But if you want to run this load test, you have to be in the directory, the parent models directory. So let me clear and pwd. So wherever you cloned that repo is where you need to be. So let's run a quick load test. Well, that wasn't a very good load test. It was just 1. So let's do 100. And here it's just pounding it. Looks like maybe one of the models is either erroring out or still hasn't loaded fully. But let's go over here and we can see this thing lighting up. So this is kind of cool. And we should sort of roughly see the throughput matching, the percentages that we specified. So that part's kind of cool. We could try to, do this in multiple windows. We could try to spin up cloud instances and, do this. Yeah, whatever floats your boat there to actually get these predictions. So showing this across the different clouds. Here's an example dashboard that I mentioned that physically, oh yeah, there's a question about Google Cloud ML in there. And yes, we actually do support Google Cloud ML the same way that so Google Cloud ML supports only models being uploaded. And I'm very careful to not say only TensorFlow models because they actually just released support, I think, for any Python-based model. So, they're essentially hooking into their functions feature within Google Cloud and can run, I believe, Scikit and XGBoost. But the key difference here is that with SageMaker, I can upload a Docker image. And when I have control over my Docker image, which for us is, if you follow the Docker quick start here, you'll be building a Docker image. You can upload that when you have control over that Docker image. You could use our open source Docker images that have been optimized and tuned and like reused across all of our customers. This stuff, that's like the open source stuff, right? And then community builds off the open source stuff, and then some of the advanced features like the advanced routing, and think of the ability to trigger off, it. So I'm going to load this up again in a sec here. So I could see the cost per prediction, and let's say I lose all of my AWS instances or Spot instances, and so previously most of my predictions were happening on Amazon because it was it was the cheapest per prediction. Now I lose my Spot instances, I replace them with on-demand, higher priced instances, and now Google Cloud or Azure becomes cheaper. And so these are the with this functions feature, you can build in these rules, to trigger and say when Google becomes the cheapest option, start to shift traffic over. So most people talk about auto scaling. That's a given. That's like talking about Linux or talking about, like Kafka, something like that. That's just a given. Now we have this auto shifting like technology that we've pioneered here, where we can automatically shift either across models that are performing better, and you actually define the function that is the objective, right? The objective function for whatever you're trying to optimize for. And if it's maybe it's power efficiency, so we would expose power efficiency here. You would, auto shift based on that metric. And so one thing that we do see most commonly is people that are making decisions off of price. And so this is overall across all three clouds. I can probably optimize across those for cost or for power or like latency, like whatever works for you. Okay. As kind of a general rule, we've seen, for the same price, we've seen actually Google outperforming like Amazon in some cases for some models. And it really depends on the instance type. And, these are all hyperparameters, right? So let me jump over to this view here. This is a feature that is almost done. And the sort of early like wireframe here is this. And really this is highlighting our sweet spot, which is kind of steps 2, 3, and then this 4, like the feedback loop. So everybody, stops with training. There's tons of tools. My old company, Databricks, they do training, right? There's like a million tools that train, but they don't get things to production, like number 3. So, and then in focusing on 3, what we realized was there's actually a step 2 that is completely unexplored. And so the bottom right there shows a TensorFlow graph that's literally just linear regression. It's 5 nodes. When TensorFlow is training, it's now 85 nodes or 92 nodes, something like that. And that's what people are putting into production. And that's not good. What you want to do is this post-training optimization, step 2. And again, for us, this is a checkbox. And let's see, we get to the checkbox. There. So this is literally, oh, I want to try the TensorFlow serving version, or I want to try the Tensor RT version, something like that, right? I'm going to deploy on Intel hardware. I want to use Intel's Python. But the core tenet is that we don't know how the model is going to do. This is something that was beaten into me at Netflix, where when I first joined, I like didn't understand the amount of data that they were tracking and the high tolerance for experimentation and risk and failure. When you have, and so a lot of those like best practices are in PipelineAI. So the ability to get to this screen where I've deployed a model, but you know what, it's not doing well. So I'm either going to zero it out or I'm going to just mark it for deletion. This particular model is doing really well, so I'm going to shift more traffic to it. These are all very, very powerful things. And this is the data scientist that can do this, right? Some shops don't necessarily want the data scientists to use this, but we like that because we know that data scientists like data, and all they want is a dashboard, and we're providing a whole ton of dashboards. So we could shift traffic that way. The data scientists can also look at more complex dashboards with Grafana and historical dashboards. They can run Spark jobs to label data. So this concept here is prediction accuracy, right? This is, so yeah, back to the screen. So here's training, right? This is familiar ground for most of us, training accuracy, training time. We actually have a training cost that didn't make it on this slide, but where, because you're using GPU, this is a higher cost. But it's a much higher training accuracy than the cheaper Scikit-Learn version. Here's the optimization step. So this is where we would say we converted to TensorFlow serving. The checkbox for 8-bit quantization, 16-bit quantization, right? Like these are the very, and so we're tracking this. We're putting each row here is a pipeline, and some people call it variance, but it's a pipeline to get to a model that's in production. And how did it get there? We're tracking the whole thing. We're tracking all the metrics. This is another really pipeline API, CLI. This is Python code that you would put into your Spark job, your Spark training job, and you would also put it in your optimization code, or we'll put it in there for you. We'll actually auto-generate it and track these things for you. We'll convert this gigantic 92 node thing down to 5 nodes, and we'll apply 8-bit quantization, or we'll actually round them all so that we can compress them better to fit onto the like Apple rather App Store for like iOS App Store, things like that. They have very strict like limitations on the size of an asset, a single asset within the App Store, and if it's 100 meg or whatever, and your model comes in at 102 meg, it will get rejected. So these are some of the optimizations we can do. Also, like I said, you can play with the timeouts. You can adjust the this concept of the request batch window. So this works across all the models, not just TensorFlow. TensorFlow happens to handle this natively within TensorFlow serving, but we do this for Python models, we do this for Java models, PMML models, PyTorch models. Yes, we do this for everything, where we will batch up. If you tell us 50 milliseconds, which this would normally be configurable, but it's just a checkbox, we will actually wait 50 milliseconds and take all of the prediction requests that come in onto that single model server. So one of these servers down here would be, we could actually tell it, wait 50 milliseconds, take everything, make one big prediction. And because of the properties of linear algebra, we could actually slice those results that come back from this massive matrix multiply, which is super optimized because it, we're like using AVX and like MKL, and we're using vectorized like constructs. These chips can handle it. Like GPUs love batches of data up to a certain size because GPUs do have limited memory. And so we'll actually batch those up, make one big prediction, or pass one big batch to the GPU, make a huge prediction, bring it back, and we're able to actually slice up the results that appeared as one result. But because we construct it beneath the covers, we can actually slice that result and send it back to the caller in Japan, the caller in Sydney, the caller in San Francisco. So that's a really powerful feature. That's a model predicting hyperparameter. So what I've been talking about, these knobs you can turn, like this entire thing is, yeah, so these are all hyperparameters. We like to use that term between each other, but, and with data scientists, but there's like a lot of folks that think that's kind of a weird term for it. So we just call them options in the UI, but these end up being distinct Docker images. We push them out quickly into production. We load test them in mirror and shadow mode. So one thing to point out is that this particular model name is taking traffic, but it's in shadow mode. And so we should, if I go back to the screen here. So if I load this up And we could certainly do better about, like marking which ones are in shadow mode. That's a feature that's on our backlog. But, here we're running, this thing is taking traffic, but it's shadowed traffic, meaning I can compare it to the other models that are actually like responding. But here, this is like literally just taking best effort. And the cool thing is that this is all the same data going to all, or to all of the shadows. Like I can now compare how the shadow did with the exact same data as, these other live models. So that's really cool. So you could actually build a dashboard where you are comparing those. I mean, here's just a quick view. It's not really showing any predictive metrics, but the predictive metrics are what you want to look at. And that ties back into this last section here, which is, these are our hyperparameters. So which prediction engine? Is it TensorRT? Is it just Flask app, in Python? Is it, am I running on Amazon? Am I running in the White Plains data center, fictitious White Plains? Also this, wireframe hints, and, this is essentially a combination of our two things here. It would be like this view plus this view plus this view, and then a dashboard as well too. So we're striving for this. It's a little bit busy when we do it like this, so that's why we split it up this way. But this concept of a prediction accuracy, so this is very important. This is right now when the first time the model goes out, it's pretty much matching training accuracy, and that's good. It doesn't always happen that way, which is why you would put the model in shadow mode first and then slowly shift traffic to it if it was completely failing because of some bug on the training side. This happens all the time. This is like a huge reason why people come to Pipeline, is that they want to put a model variance, make a small change at training time and see how it does live. And so this is starting off pretty good, but actually over time, and this isn't represented here, I just have to talk through it, as over time, this prediction actually degrades. And how we know this is we have the ground truth of what fraud is and isn't. And what we would do is tie a Spark job to, this Spark job becomes the function that this prediction accuracy is using to calculate, right? So some of these are as simple as just like looking at a database. Some of these are more complex and have to run a 24-hour job on who signed up, which campaigns did they use, which of these model variants were part of those signups, probably various things. So you could take your existing Spark jobs, plop them in here, and use them to actually define a metric. And then we could trigger off of this metric, and we could actually, if we had 4 or 5 different variants, we could actually start to move traffic using our multi-arm bandit support, where we're moving traffic from a poorly like degraded model versus a new model that's come on the scene that's doing really, really well. The like traditional cases, you push out a fraud model that's preventing fraud, and the adversaries, the fraudsters, figure out the model, right? They start poking it, they start passing different inputs, and they actually train and learn your model. And now they're able to continue fraud. So these models degrade over time, which makes them very different than classic microservices, which pretty much do the same thing that they do right when they deploy to the day that they're torn down. Whereas these things do have a sort of stochastic aspect, and and so this is where Pipeline comes in. A lot of real-time AI, the ability to actually create these custom metrics, to trigger off them, to shift traffic between 2 variants, or even shift if one variant was, so here, like we would actually shift traffic from Amazon to the White Plains data center. And that just ended up, being the best way to serve at that time, optimizing for both accuracy and for cost. One last thing to point out is there's this efficiency score that we allocate, and there's, you can customize how this is defined, obviously, by using a function. What we're doing here is we, by default, kind of have a balance of prediction accuracy and prediction cost. And then, yes, also we take into account the training costs as well. So training costs, which isn't shown here, but when this model was initially trained, that first variance there, that model was trained on a GPU. It trained for 270 seconds, and it cost, you know, $5. Then we compare it to the second one. So actually, when these models first go out, the more efficient model at the time is the that second variance. Even though it's not predicting as well online, it was much cheaper overall. It was much like more efficient. But as time goes on, we're sort of amortizing the cost of that initial training. And now, because it's so cheap at like prediction time, you start to see where you can cross over and actually start to become more efficient than that first one. So this is purposely put here as a lower number, even though it's counterintuitive because of the cost. But really, this efficiency score for this particular model was set to include training cost as well. Okay. So I think there's some questions here. We're already 15 minutes over. What are the dark circles? If you could send the link about the dark circles, I can answer that. Google Cloud ML Engine, yes. Like I said, we are gonna, we do support it. The difference is that they don't support Docker images, so all you would be uploading is essentially this archive that we created earlier. So when we did the model model archive tar, that's what you would be uploading. Is there some sites where you guys show today? I want to pass on the yeah. So let me get you a link to, actually, if you go to, we have videos and slides, everything. I'm actually doing a workshop this weekend on Saturday, like I said. I think I pasted that. That's YouTube. Slide share. Let's share docs, PipelineAI has a bunch of stuff. I'm from Chicago, and I'm going to be there, I think either it's going to be next month. I'll be there sometime in July. I don't have anything formal set up, but I could certainly try to get something set up. I also do, so the upcoming ones are not just San Francisco. So I go back to that meetup. Let me be clear here, which I did not make clear. This is actually online as well. So I do it both ways, where I have people dial in and they get the exact same experience because we're using the same tools here, Zoom, online or in person. We got a bunch of people signed up. It's going to be a good time. You will get your own instance, and you will be using GPUs, and there's a TPU section as well. Not a specific learning path per se. I'll just close in the order. Yeah, our focus, we're a pretty lean startup, so our focus is any of our teachings now come through the products or through the community edition specifically. And the more and more that you interact with the product, the more questions you can ask, and really follow the quick start is really the best place to get started. Let's see. Here's the quick start. Oh. Nothing happened. Okay, no. Yeah, I see. You could try www. You can try that one. I should probably change the, yeah. Okay. So we'd love to see you guys again. Next time we're going to do some of the Jupyter notebooks. Try to catch us on Saturday, this Saturday coming up at 9 a.m. Pacific time. Hopefully that works for some of the overseas people as well. And hope to see you soon. Thanks a lot. Ask any questions on the Slack or shoot me an email. I'm chris@pipeline.ai. I'm not very good with email, so usually Slack or the little that dark circle thing in the bottom right should do it. Thanks everyone.